Okay. How to do a good API? So I think there's like a couple of basic things that I think is important. Try to design APIs for like with a view of what they do, not what they're used for. And that might seem like, not a huge difference, but think about it. It's like if you've done anything with graphics, like for instance, in graphics we talk about texture, like you texture an object, and it's a really bad name because texture actually means something. It's like the texture of a surface. But what really a texture in graphics is a bitmap lookup table. And you can store any kind of data. You might have bump data, reflection data, like anything, right? Or it can be a lookup table for a reflection function or whatever. You can use it for whatever. And texture, like as in touch, is one of the many uses. So if you design your APIs and naming things after what they're supposed to be used for, you sort of are very narrow-minded. You're saying like, oh, this is the thing for textures. Therefore, you want all the things that have to do with texture. But then people are going to take that and use it for something else, and then your assumptions are going to break. So it's better to write APIs and things that are just there, and they say, here's what I do, what I'm used for, that's up to you, right? So I think it's a good start, right? Because a lot of times you sort of decide up front what things are going to be used for, and that limits how you in the future want to use them. I think that you can look at my APIs. So let's look at a simple one. Like Imagine. Imagine is my my library for like everything that is system dependent and needs to be portable but isn't. That doesn't include graphics or display or something like that. So if you want to run an application that sort of runs a little command line tool, like a window like this, you don't want to open a window, you don't want to use, mouse pointers, you just want to have a little thing. So this is it. So the things I do here is I make very clear sections. So this is one API that does many different things, right? But they're clearly sectioned. They're clearly, they're in one header file. I try to make the header file as readable as possible, right? And then you sort of, you do things. I tend to, prefix everything. So everything that has to do with library is like imagine library interface. So here's like, you can load in a library, and then from the library you can create an interface. So yeah, it sort of makes it easy to navigate, right? Some of the things that I do lately, which is like my more modern APIs, is I do debug functionality built into library. So if we search in this project after Phobos error, here are a whole bunch of printfs all over the source code. You can go to any one of these, and it basically will say, here's a function, and if you give this a bad value, it will like give you an error, right? And as you can see, I have a debug mode, which is defined, and when that's turned on, this test will happen. So obviously this test costs, a couple of cycles, and I want to have those cycles, for debug stuff when I'm releasing the game. So that's why there's like two sides to everything. You can see there's like, lots and lots of, probably 50 of them here. 72 of them actually. But there's actually more than that, because you can go to like Titan error. That should be Titan. Do we have? There should be like Yeah, well, we have a warning here. I usually, strange. Usually I have them so I just started with Alara. So there's one error so far, but there's going to be more and more errors. So you create these errors and warnings so that whenever somebody uses the API, it's like they get a clear, like, hey, you did something wrong. Here's what you did wrong. Fix that thing. You can't move past this point with that, variable being invalid or something like that. That's super useful. What else could I say? Sometimes I make multiple APIs for the same thing. So here's Marshall, which is a crazy project. But an example of that might be Marshall. So Marshall, if you want to create, it's a key value store, if you will. And the way you can get or set a value is like you can, I'm just going to show you parts of it, but so if you have a data structure and you want to know what's inside of it or you want to read it, you can, can use this function to add a member to a struct, right? With all these parameters, right? And therefore you can build up your thing by calling this a lot. You can also create a struct, this thing, by giving an array of all the struct members all in one go, right? So it does the same thing, it's just a different way of doing it. But then you can, you can access members by reading or writing. So this is an access. You say this is a member, this is the allocation I want to access it, blah, blah, blah. Here's the value I want you to read from or write from. But I can also say, if it doesn't exist, create it with this data structure, right? So this is kind of, a lot of blabbing, right? But then you get down here and here you can say, well, I can just set, root set text. So basically, I want to set the key and the value of text. And I will set it in the root because you have multiple data structures, right? But then you can also say set create, meaning if there really is no key value, create one, right? And then there's one that says detail, which is like, if there isn't one, create one, and here's the comment I want to put in, here's the default value, here's the unit, right? And then you can go further down and say okay, so you can set with an index, you can set with, create with a buffer, and you get these longer and longer functions with return codes for errors and all those things, right? So it's how complicated of a thing do I want? It's it depends, right? So I have a lot of functions where you can basically only get the parameters you want for whatever, right? So there's many, many ways of accessing the same data, right? Depending on, And then you can also call things like Marshall print. So if you have a structure, just print it to standard out. I don't want to have to parse through it. I just want to see it because I'm debugging, I'm working on something. Just print it for me, right? And here's another way to do it. It's I want a data structure, but I have a type def that I've written in C. Take that string and turn it into a data structure, right? Because I don't want to have to call a bunch of APIs. I've already written my structure. Use that, right? So there's many, many ways of doing it, and sometimes it's really good to design an API with the user in mind and saying sometimes you want it like this, sometimes you want it like that, and you write multiple ways of doing the same thing that fits different use cases, right? I tend to think that it's good to use the same structure multiple times. I'd say that.